All right, I only posted one assignment for this week, but it's a longer lab. And it's again using PhET, but this one's called Forces and Motion. And it's looking at force, friction, and acceleration. For the first part, you want to be on click the motion tab, and that's going to open up. Well, I was already using it, so let's reset. That's going to open up a screen that looks like this. Before you're starting, there's a little bit of vocab to go over. The first one here, what is net force? And the definition is the combined force acting on an object. So it's going back to the tug of war example of last week, and you have someone's pulling to the right with 10 newtons of force, but somebody's pulling to the left with 15 newtons of force. The rope goes to the left with 5 newtons of force. That's the net force acting on that rope. Now, yes, there's other forces there, but we haven't gone over that until this week. Acceleration. You've probably heard acceleration if your parents are driving and they're getting on the highway, they start to accelerate on the on ramp to get up to speed. So, acceleration is a change of speed over time. And you can feel that when they are start to go faster, that you start to go into your seat more, right? And that changes speed. You can feel that also on roller coasters because they're constantly accelerating as they change directions or as they go down, they start to go faster. Friction is a force that opposes motion. So any time there's two surfaces that are touching, there's going to be a little bit of friction there. So energy is going to be lost. If you roll your skateboard down a street, the reason why it stops is because there's friction between the wheels and the road. Now, there's also other things at play here, like air resistance, but for the most part, there's friction that's opposing the motion of the skateboard. All right, so just to get into this, part one, in this simulation, the skateboard is used to represent no friction. Okay. Why is it important to know that there is no friction present? Because you take out that force. So we're on forces in motion. We're on the motion tab. So your screen should look like mine here. It does tell you to play around with it a little bit just to get familiar. You can check out the values, the masses, the speed. You'll have a speedometer that comes up so you can see how fast things are going. And then just follow the directions. So number one, place a box on the skateboard. Okay. And then set the applied force, which is down here, to 100 newtons. You can change the force by 1 by clicking on just the 1 arrow, or you can change it by 50 by clicking on this double arrow. So if you're applying a force of 100, that's pretty easy to do. Now you can see what happens to the speed over time. So it starts off slower and it gets faster and faster and faster. So that's acceleration. The wooden stick guy here is who's applying that force of 100 newtons. All right, and now it says place a refrigerator on there and look at what happens. So this is more mass. And we're going to set that to 100 newtons again. And you can see the speed going up. Is it going up as fast? It's going up a little slower. That's what you should notice. And then it asks to put both of them on there. And again, apply the same amount of force and see what happens to the speed. So that's even slower. And then it asks you to set the force to 300, reset the simulation again, and put any two objects you'd like and a force of 200, and then answer the questions down here. Part two. Constant force with different mass. You'll be using the simulation to design an experiment. A data table named constant force with different mass has been provided for you to help you with the planning of the experiment. The question that we're asking in the lab: how does increasing the mass of an object while using the same amount of applied force affect the motion of the object? All right, back into the beginning of the year and throughout the year, we looked at variables of experiments. The independent variable, it gives you a hint there, manipulate it. It's what you as the experimenter are changing. What are you going to change in this to answer this question? You're going to put that here. And then the responding variable, what does that affect? Whatever you changed is going to affect another variable. What's being affected is going to go right here. And then you have constants, what's staying the same. It even tells you using the same amount of applied force. So that would go here. That's staying the same. Make your predictions of what will happen to the acceleration, which is a change in speed, as the mass increases and the same force is applied. So you can even see here that this force is staying the same over time or staying constant. The mass is being changed by you. So that tells you what variable it is. Here's where you're predicting what happens to the acceleration. Put a 0 if you think there would be no acceleration, so no change in speed. Put 1 if you think it's the slowest acceleration, and then 5, up to 5 if you think it's the fastest acceleration. And then put the actual observed acceleration here. And then there's a couple questions to go with that. What do you notice happens as you increase the mass? And then explanation for how does increasing the mass of the object affect the motion of the object. Part 2B, now you're looking at a different force with constant mass. So the mass is staying the same. So down here, that's what you'd be putting for the constants. Now the question is, how does increasing the amount of applied force affect the motion of the object? So what are you going to change? That's going to be your independent variable. What's being affected by that change? The motion of the object or the acceleration. That's going to be your dependent variable. Make sure friction is set to 0 so you don't have another mass acting on it or another force acting on it. Okay, and you're changing the mass. For these, part 2, you're using the acceleration tab. I should have told you that earlier. So you're not on this anymore. You're down here, the acceleration tab. And you can check that all of this is checked to make sure friction is set at 0. So again, you can change the mass. There's different masses here. And then you're applying the same amount of force for 2A. And then looking at what happens to the acceleration, which is right here. And part 2B, you're keeping the mass the same. So you're not changing the mass and you're changing the applied force and then looking at what happens to the acceleration. All right, I hope that helps. Let me know if there's any questions and I'll go over it on Thursday during our meeting.